My name is David Bishop. Today is October 30th. I will be performing experiment 4 for EET 238 Digital Fundamentals. And the purpose of this lab was to create a full adder as well as a half adder circuit. So on my breadboard here, I have my half adder circuit on this side, and I have my full adder circuit on this side. And what should happen is as I toggle switches between the adders, then what should happen, depending on the position of the switches, particular lights should light up based on the actual input. So for a half adder, at least from the truth table I have, when both switches are in the off position, such as they are now, the lights will be off. However, if switch 1 is low and switch 2 is high, it should create a sum, which would be this light, here, because this is a output of the X4 chip here. Now, if I change positions for switch 2 to low and switch A to high, then what should happen is this light should go out and this light should come on, because this is the output of the AND circuit. And then when I have both of them high, I should only have one light lit up, which would be the carry. However, unfortunately for us, this lab has not worked like it was supposed to. It does kind of work, but it did work the first time I put it together, and then it just stopped working. So this is not going to be a complete success, at least not for the half adder circuit, but we're going to go ahead and test it anyways. So here we have switch 1 and we have our switch 2. So my switch 1 is connected to my XOR and my switch 2 is connected to my AND. So as I go over here and make changes, and it looks like my arm's kind of in the way, as you can see, I've actually turned on one of the switches, but actually both lights have lit up. This light here has lit up as well as this one here, and it wasn't supposed to do that. And if I turn off this, it goes back to that, and I turn on switch B, same thing happens, both light up. However, if I put them both in a high position, then it gives me just a carry out. So what should have happened is I should have had a sum light up when there was a sum, and the carry light up when there was a carry, not both of them lighting up at the same time. And then when I had a number that was too high, the carry should have been the only light that lit up. So in this experiment, my A and B in the off position did generate no signal, and both of my positions in a high did create a carry out here. However, whenever I went into my actual mixed switches here, it gave me both lights lit up, and it's not supposed to do that. So this part was, I guess, partial success, except for some odd reason, the sum and the carry did not work as designed, even though it did work the first time I tried it. All right, now we're going to move on to the full adder circuit, and this one actually worked like a charm. So here we have our 3 switches that are going to represent our 1s and our 0s. So the way this should be set up is this would be switch A, B, and C. And what should happen is as I change the position of each of these switches, these lights should toggle through different cycles depending on the actual inputs. So we'll go through this fairly quickly. We're going to start with 001. Our sum lights up. Our 010. Our sum lights up. Our 011 should give us a carry out. So 011, we have a carry out. Put these back into normal. Then we should have 100, which should give me a sum, which it does. Then we have 101. 101 should give me a carry out, which it did. And then we would have 110, which should give me a carry out, which it did. And then we have 111, which should give us both a sum and a carry out. So ideally, this one worked out the way it was supposed to. And as you can see here, this is utilizing our XOR gate here. We're technically 2 XOR gates, 3 AND gates here, and 3 OR gates here to toggle between the lights based on the position of the switches. So for the full adder portion of the lab, this actually was a success and it worked as it was designed.